Hello everybody and welcome back to the last tutorial of Nmap scanning section, and right now what we're going to do is we're going to navigate through the manual of Nmap and see different types of things that we might have skipped in the previous tutorials. So right now, as we are already introduced with this, at the beginning we will have our regular menu or a regular help menu that you actually get as soon as you open up Nmap in your terminal. So let me just lower this. I will put this to the right side and open another terminal right here from which we're going to run our commands. Okay, so right here, if we go down here, this is the menu that we get just by running the nmap command, as you can see right here. And what we're interested in at the moment is the TCP scans that we can actually perform using the nmap. Now, those are the TCP scans that we didn't cover yet, and here are the first types of scans. Now let me just see right here, these options right here we are not currently interested in. What we are interested in is scrolling down to the SYN-ACK and TCP SYN scans, which are right here. Okay, so we can see that we have the option -SS, which is TCP SYN scan. As it says right here, SYN scan is the default and most popular scan option for good reasons. It can be performed quickly, scanning thousands of ports per second on a fast network, not hampered by restrictive firewalls. Okay, so this is simply just a normal scan that you can run simply just by typing -SS and then the IP address. Let's say we use my laptop's IP address, and you can see it has already finished. It found one open port, which is TCP 80 over HTTP, and you can see it has finished the scan in 0.79 seconds. There are different TCP scans that you can perform, which is the TCP Connect scan. Now this scan right here will be a little bit longer because it is going to perform the three-way handshake or the full TCP connection to the target. Therefore, you will notice that it will not be able to actually finish it as fast as it has finished this scan. So if you simply just use the same command, let me just go right here and nmap -SD and then 192.168.1.15, press here enter. As we can see, it finished in 5 seconds. Okay, so the next thing that we're interested in, or that we can actually cover, is the SU, which stands for UDP scans. And what I would advise you is, for all of the options that you're actually going to use, I would advise you to actually read through the Nmap manual, because it gives a detailed look at each and every option in the Nmap, and you can learn most of the things just by reading this manual right here. Okay, so the UDP scans are mostly used, as it says right here, to scan like a DNS server or something like that, or SNMP or DHCP. As we can see right here, while most popular services on the internet are run over the TCP protocol, UDP services are widely deployed. And we can see DNS right here, which is the #1 reason that you might actually need to use the UDP scans. And the actual problem with UDP scans is, as it says right here, a big challenge with UDP scanning is doing it quickly. Open and filter ports are rarely send any responses, leaving Nmap to time out and then conduct retransmissions just in case the probe or response were lost. Since the UDP is connectionless scan, we can't really determine whether all the ports will send any response back. That's why TCP is scanned that most of the time you will use once you scan your targets, unless you actually try to scan a DNS server or something like that, you will then use UDP. Now, this is the scan that I was talking about before, which is SA, stands for TCP-ACK scan. As it says right here, the scan is different than the others discussed so far, in that it never determines open or even open filter ports. So with this scan, you can't really determine open or filter ports. It is used to map out firewall rule sets, determining whether they are stateful or not and which ports are filtered. The ACK scan probe packet has only the ACK flag set, unless you use scan flags. When scanning unfiltered systems, open and closed ports will both return an RST packet. So if we simply just try to go with the SA, you will notice that we do not get any different response while scanning, for example, my laptops. We will just type right here nmap-SA and then 192.168.1.15. Or we do actually get, yeah, because this is actually SA, it doesn't really determine whether a port is open or closed. As you can see right here, the difference between these two outputs right here is that this output right here does give us a prompt of the 80 TCP open port over HTTP, while as this one doesn't give us any open ports, and it actually says right here all 1000 scan ports or on this IP address are unfiltered. Okay, so that is also a good output to have, as it says are unfiltered. Therefore, we know that there is not any firewall that is behind them. Okay, so let me just clear this out and open up the manual once again. Let us go and see another option that might be useful to us. We already did cover TCP window scan. The SA scan is something that we did right now, and you know that we actually got unfiltered port, or all 1000 ports are unfiltered, and we can see Nmap then labels them as unfiltered, meaning that they are reachable by the ACK packet. So all the ports, all the 1000 ports were reachable by the ACK packet, but whatever they are open or closed is undetermined. Ports that don't respond or send certain ICMP error messages back are labeled filtered. So we now for sure know the ACK packet was successfully able to reach those ports, but not determine whether they are open or closed. Okay, so let's go to some different scans. As we can see, SO IP protocol scan, but that is not really something that you can use all the time. Now you can scan different ports one by one if you want to, so simply just by going nmap and then 192.168.1.15 and then specify -p, and we want to scan port 80 only. You will only get result for port 80 saying port 80 is open, which is correct on my laptop, but if you simply just specify port 81, you will get that port 81 TCP is closed port. Okay, so you can simply just specify a port at a time, or if you want to, you can specify multiple ports just by specifying them separately by comma, so -81, 82, 83, and you will get result for all of those ports. As you can see, they are all closed on my laptop machine. Okay, so that is one thing that you can take a look at with these port ranges and specify only one port. You have -F option, which basically stands for fast scan, as it only scans 100 ports instead of 1000. So if you perform a normal Nmap scan, it will by default scan first 1000 ports that are mostly used on systems, such as for example port 80, port 22, port 21, and basically top 1000 ports, while as if you specify -F, it will specify only first 100 ports. As we can see right here, specifies that you wish to scan fewer ports than the default. Normally Nmap scans the most common 1000 ports for each scanned protocol. With -F, this is reduced to 100. Therefore, it will make this scan a little bit faster. So if you just simply type nmap -F and then 192.168.1.15, press here enter, it scanned only top 100 ports, and of course in those top 100 there is a port 80, and we get the same output. Therefore we scanned only 100 ports, and the output right here, it says not shown 99 closed ports, while as in the other scans it would most likely show right here 999 closed ports or 999. Okay, so you can also, if you want to, scan all 65,000 ports, simply just by specifying nmap and then -p, and then simply specify our range report, which is 1 to 65,335 or 65. I believe there is that much ports. Let me just see. Well, I just leave it 65,000, doesn't even matter. You can scan all 65,000 ports. Just by specifying it like this, just it will take a little bit longer. We need to add dash right here, and now it will scan each and every port in this range. So let me just see right here. As you can see, it does go a lot slower than before. It is only on 40% by now, and at the end you will see all the open ports in this range, which I believe will still only be port 80, but we will see in just a second. 95%. Okay, so it is almost done. As we can see, the only open port on my target system or on my laptop is port 80, and it did scan 65,000 ports, as it says right here, 64 and then 999 closed ports. Okay, so that is also something that you can do. Let us see whether there is anything more interesting right here. Now you can also read through all of these other options right here, such as the -R, don't randomize ports, ports ratio, top ports, and so on and so on. Service and version detection. Now this is an important part if you want to detect the services that are running on a target system, and you also want to detect which version of services are running there for your future scans, where you can actually determine whether those versions are vulnerable to some exploit or not. You can add the option -SV. So the option -SV simply will scan for the version of a service running on an open port. So let's specify, for example, 192.168.1.1, which is my router. Now this scan can take a little bit longer, but since I'm scanning my own router, it will not take too long to finish. And what it should prompt us with is all the open ports, all the services on those open ports, and the version of the services that it could get. As we can see right here, on my router, it discovered 3 open ports, and simply you can see port 21, which is an FTP port. We can see the service that it is running is FTP, and the version of FTP is this one, so Netgear Broadband Router. So we can see that it was able to actually determine the version, port 80, which is running over HTTP. We can see that the version was this one. And now what you would do in a vulnerability analysis, which we're going to cover later on, is possibly just copy this, paste it into your Google, and simply just find whether there is any type of exploit for that specific version. And if there is, good for you, then you can start planning out your attack for that specific open port, which is vulnerable. If there is not, you simply just go on to the next port and do the same. So we can see we were able to recover 2 different versions, which is really important for us for our future attacks. Okay, so if you want to, for example, specify also multiple things at once, you can simply just do that nmap, and then let's use -SV and then -SC for running scripts or nmap scripts. We can also specify that we want to scan only top 100 ports just by simply specifying the -F option. We can also specify that we want a decoy, which is going to have random 10 IP addresses, also sending packets to our target as well as we do. And let's see what else we can do. We can fragment our packets into a smaller one, so we can try to actually bypass some kind of a firewall if it was there. And then we can specify that we want to actually scan our router. Press here enter. Okay, so you can see we did get some kind of an output. So nmap scan report for our router. It only scanned 100 ports. It discovered 1 port open for some reason, because possibly these 2 are not in top 100. We can see that it managed to actually discover a lot more information about port 80 just because we actually added this option -SC, which stands for basically running default scripts. We can see the port is open. Of course, we get the version because we use the -SV option. We get the HTTP authentication on authorized because we got the 401 message. Basic realm home gateway. Now we know what this is. It is a home gateway, even though we actually knew it even before. HTTP methods, as it says right here, it gives us potentially risky method is put. HTTP server header is this one. HTTP title, protected object. That means that there is some kind of a password once you actually want to go to that page, which is correct because we need to enter our router from there. It also gives us the MAC address. Now, if you don't want to use the -F option in order to get out more details, you can simply just remove it. Perform the scan once again. It will go a little bit slower because right now, instead of 100 ports, you're scanning 1,000 ports. But it should finish in just a few seconds. As we can see, 66%. It is undergoing SYN self-scan. And if you wanted to, for example, you could have used Windows scan, TCP Windows scan or something like that in order to even more be sure that you can bypass the firewall. And you could have also used the actual spoofing of your source and of your MAC address. But I will leave up to you to actually experiment with all of that. We did add a bunch of options in this scan. And let's see what kind of output we get right now. So once again, we, for some reason, weren't didn't manage to actually find out more information about port 21. So let's see if something like this will change it. So if we simply just add -p for port and add 21, press here enter. Yeah, as we can see right now, it is not even there. I believe it was open before, or it could have been port 23 right here. So let's perform the same actual scan on port 23 to see what we can discover. And you can see right here also the port 23 is for some reason filtered once you actually use this scan instead of a this scan, because some of these options right here could present a problem for the actual firewall, and therefore it might actually block out our incoming requests, or it might actually show us a different result, such as here it says port is filtered, but in the previous scan, once we actually scanned the same port, it said that the port was open. It even gave us the actual version of the software running on that open port. So the best thing you can do is experiment with different kinds of options, as we did right here, and see what kind of output you will get for different scans. Of course, once you are actually performing real-life scans, make sure that you actually spoof your IP address and spoof your MAC address for performing anonymous scans, and you will be good to go. Experiment with the Nmap manual, learn as much as you can from the Nmap manual, and in no time you will become the Nmap expert and you will perform all kinds of scans that you need to perform. Okay, so basically that will be about it for this Nmap section. We did cover some of this stuff, such as, for example, scanning different versions, bypassing honeypots, firewalls, bypassing IDS and IPS. We saw how we can fragment our packets, spoof our source addresses. We also saw how we can create decoys, how we can scan with different scripts using this -sc option. Now, I'll leave it up to you to experiment with the rest of the settings. And I hope I will see you in the next section, where we will actually cover a little bit of Nmap using the vulnerability analysis. Hope I see you there, and take care. Bye.